Okay, I thought it was important that we start off the first lesson of algebra with a little bit of fanfare. You may have recognized that. That was the Olympics theme music. Um, Not that this is going to be, a sprint, but this will be a marathon, and I think we will do fine with this. Okay, so today's first lesson is going to be on variables and grouping symbols. This is review. It's actually covering two lessons from the textbook, but I wanted to cover it in one lesson since I think it'll be easy enough for you. Okay, so let's get started. So we're going to be talking about simplifying numerical expressions, evaluating algebraic expressions with or without grouping symbols. Okay, so when you go to an ocean beach, you may find small shops that rent recreational equipment such as scuba gear, surfboards, and snorkeling gear. You can also get chairs and umbrellas and stuff. Suppose the rental charge for snorkeling gear is $4.50 per hour. The amount you'll pay for using the gear depends on the amount of time you have it. So the rental charge follows this pattern. So here's your rental charge. It's $4.50 times the number of hours, or $4.50 times H. The letter H stands for the hours shown in the table. So here, if we look at this, we're looking at 1, 2, 3, and 4 hours. Also, H can stand for other hours that are not on the table, and we call H a variable. And a variable is a symbol used to represent one or more numbers, and the numbers are called values of the variable. Now, the reason we call it a variable is because it varies. H may represent one number in one situation, and it may represent a different number in another situation. So it varies depending on the situation. Whereas regular numbers like 1, 2, 3, and 4, we refer to as constants because they don't change. Okay. An expression that contains a variable, such as the expression $4.50 times H, is called a variable expression. And you learned this in pre-algebra. An expression is just a collection of numbers and operations, and a variable expression has numbers, operations, and variables in it. So an expression such as $4.50 times 4 that names a particular number is called a numerical expression. Okay, this is a numerical expression because there's no variable. Or we just call it a numeral, okay, because it represents a number. Numeral is just a fancy way of saying number. Okay, so this represents a number. Another way to indicate multiplication is to use a raised dot. For example, $4.50 times 4. Notice that my decimal is down here at the bottom, and this dot is kind of in the middle. Okay, that indicates multiplication. In algebra, products that contain a variable are usually written without the multiplication sign because it looks too much like the letter X, okay, and X is our most common variable. So we don't use the cross anymore to represent multiplication. Instead, we use the dot. We might use parentheses, or when you're multiplying a number times a variable, there's no space. The number always goes in front of a variable, but this is called implied multiplication. So this is 19 times n, and a times b, and 1/2 times x. This can also be written like this, as x divided by 2. Okay, the number named by a numerical expression is called the value of the expression. Since the expression 4 plus 2 and 6 name the same number, they have the same value. To show that these expressions have the same value, use the equal sign. Okay, so this is an expression with a value of 6, and this is an expression of a value of 6. And if we wanted to show that they were equal, we would write it like that. Okay. You write 4 plus 2 equals 6. Go down where you can actually see this. There we go. You write this and say 4 plus 2 equals, or is equal to, or is 6. The simplest or most common name for the number 6 is 6. Okay, so this is the simplest way. These two represent the same number, but this is in simplest form. Okay, the symbol, and this is a equal sign with a line through it, means is not equal to. So you would write 4 plus 2 is not equal to 5 to show that the expressions 4 plus 2 and 5 do not have the same value, because the value of 4 plus 2 is 6. Replacing a numerical expression by the simplest name for its value is called simplifying the expression. When you simplify a numerical expression, you use the following principle. So to simplify a numerical expression, An expression may be replaced by another expression that has the same value. So that's the substitution principle. So basically what that's saying is if I have 4 plus 2 and I want to simplify that, I can substitute in the value 6 because it's simpler, okay, it has fewer terms, but it represents the same number, okay? So anything that represents the same thing, I can substitute back and forth, okay? So let's look at some examples here. Where am I? There we go. Okay, so example 1 says simplify each expression. So these are numerical expressions. So what we want to do is we want to see if we can reduce it down to a single number. Okay, and we're going to follow the order of operations. So we're going to take care of our parentheses first. So 42 divided by 6 is 7. Then we're going to take care of our addition, which is 15. So this is in simplest form. I can't break this down any further. Okay, I mean, I could do, 5 plus 10, but simplest form we want to have as few operations as possible. There are no operations here with 15, so that's simplest form. So we have simplified the expression. You can't solve an expression. You can only solve an equation. Okay, so if it's an expression, it's simplified. If it's an equation, it's solved. Okay, let's look at our next one here. Again, we have to do our grouping symbols first. So we're going to have 54 divided by 6, and 54 divided by 6 is 9. So 9 is the same value as 54 divided by 8 minus 2, but this is the simplest form. Okay, all right. Replacing each variable in a variable expression by a given value and simplifying the result is called evaluating the expression or finding the value of the expression. So to put that in non-math terms, basically I'm using the substitution principle and I'm going to put the number in where the variable was. Okay, so here it says evaluate each expression if a is equal to 5. So what I'm going to do is I'm going to substitute a 5 in where the a was. Because this is multiplication, 7 times a, I put my 5 in parentheses. If I don't put the parentheses, it looks like 75. Okay, so I put it in parentheses just to remind myself that I'm multiplying. And then 7 times 5 is going to be 35. So this is the value of the expression. 35 is the value of the expression 7a when a is equal to 5. Okay, so that's what that means. Again, I'm going to do that here. And this time I'm going to use a dot since I already have parentheses there. So this will be 3 times 5 plus 2. I do my parentheses first. So 3 times 5 is 15. And then 15 plus 2 is 17. So 17 is the value of the expression 3a plus 2 when a is equal to 5. Okay, let's look at example 3. Now we've got 2 different variables that we need to plug in. So I'm going to do this very carefully. So I'm going to have 5 times x is 12 minus 3 plus y is 9. Okay, I need to do my parentheses first. So 5 times 12 is 60, and 3 plus 9 is 12. And then I'm going to subtract. So 60 minus 12 is 48. So 48 is the value of the expression 5x minus the quantity 3 plus y when x is equal to 12 and y is equal to 9. Okay, next page. These all say page 1 because it's from the first lesson. Okay, so don't let that throw you off. All right, parentheses have been used to show how to group the numerals in an expression. Different groupings may produce different numbers. Okay, so if I have 150 divided by 10 plus 5, it means 15 plus 5 or 20 because 150 divided by 10 is 15. If I change the parentheses to this, 150 divided by 10 plus 5, that's the same as 150 divided by 15, which is 10. So where I place the parentheses is important, and it's important to remember to follow the order of operations. So a grouping symbol is a device, such as a pair of parentheses, used to enclose an expression that should be simplified first. Multiplication symbols are often left out of expressions with grouping symbols. Okay, so let's look at that. So here I have 6 times 5 minus 3. I could have written it like this, But if I wrote it like this, I would have to multiply first because the order of operations says multiplication comes before subtraction. But I didn't want to multiply first. I wanted to subtract first. So I put my 5 minus 3 in parentheses to indicate that this needs to be subtracted before I can multiply. Notice that there's no operation symbol between the 6 and the parentheses. That's because when you have a number in front of a grouping symbol, whether it's parentheses or brackets or braces, it's implied multiplication. So what I'm going to do is I'm going to go ahead and keep the parentheses, but I'm going to simplify within. So 5 minus 3 is 2. And now I have 6 times 2, which is going to be 12. Here I have the same numbers, but notice that I've changed the grouping symbols. Now here, the parentheses, because they're only around the 5, really don't count as a grouping symbol. It's really to indicate multiplication. So we wouldn't do this first because of the parentheses. We would do this first because it's multiplication. So 6 times 5 is 30, and then 30 minus 3 is 27. So the same numbers, but the parentheses are in a different place, so it gives us a different answer. Another grouping symbol, first let me draw these. So usually your grouping symbols go in this order. So the smallest are parentheses, within parentheses or can be within brackets, brackets can be within braces. Another grouping symbol is the fraction bar. Okay, here I've got it in red. And this counts as a grouping symbol, and it also counts as division. Okay, so if I wanted to simplify this, the fraction bar tells me that I have to simplify the top first, and then I have to simplify the bottom, and then I can cross that bar. I can't cross that bar until it's separate, until it's simplified. So let's do example 5. I'm going to simplify 12 plus 4, a little arrow here, which is 16. That's as simplified as it can get. And then I'm going to simplify 15 minus 7, which is 8, and that's as simplified as it can get. Now I can simplify the whole fraction, or I can just divide. So 16 divided by 8 is going to give me 2. Okay, so this counts as a grouping symbol as well, and basically the way it works is the numerator has to be simplified completely, the denominator has to be simplified completely before you're able to do anything that crosses that bar. Okay, so throughout your work in algebra, you will use these symbols. So these are parentheses, these are brackets, this is a fraction bar. You'll also see braces. We use braces as a grouping symbol. We also use braces to indicate a set of numbers. Okay, so that has kind of a two different uses. Okay, and if an expression contains more than one grouping symbol, first simplify the expression in the innermost grouping symbol, then work towards the outermost. So you start on the inside. If we look at this, you start on the inside and work your way out. Usually the parentheses are the inside, and parentheses are within brackets, brackets are within braces. So that kind of gives you an idea of where to start. Sometimes you will see nothing but parentheses, and that can be very confusing, which is why we use the brackets for our second level and braces for a third level. Okay, so let's look at example 6. We have 18 minus the quantity 52 divided by the quantity 7 plus 6. So notice that the parentheses are within the brackets. So we're going to take care of the parentheses first. And what I'm going to do is I'm just going to rewrite everything. And then I'm going to simplify my parentheses. So 7 plus 6 is 13. Okay. Because I still have grouping symbols, I need to continue on. So I'm going to rewrite it. 52 divided by 13 is 4. Now I can do my subtraction. 18 minus 4 is going to be 14. Okay, so because you had two sets of grouping symbols here, the parentheses indicated that it was the innermost. So that's where you start, and then we worked our way out. Okay, we took care of what was happening outside of the grouping symbols last. All right, here's some little rules to follow. When there are no grouping symbols, simply simplify in the following order: multiplication and division in order from left to right, addition and subtractions in order from left to right. And this is just the basic order of operations. Remember, you're going left to right. So multiplication doesn't always come before division. You do these two in the same step. It's just whatever you hit first. The same with addition and subtraction. Addition does not always come before subtraction. It's whatever you hit first, going from left to right. So let's look at example 7. Okay, so here we have 29 plus 15 times 4. Multiplication comes before addition. So 15 times 4 is 60. Okay, and now I can add, and that gives me 89. If we look at this next one, I've got a multiplication and a division. So I'm going to multiply this first, and then I'm going to divide. So if I multiply this, this is going to be 24. And 24 divided by 8 is going to be 3. So this is going to be plus. Okay, it's important that you write down everything else to get to the next step. If you try to do it all in one line, you're going to make mistakes. Okay, so now I'm going left to right, and here's an example where I have subtraction before addition. I have to go left to right, so this has to be done first. So 19 minus 7 is 12, and then 12 plus 3 is 15. Okay, let's look at example 8. Evaluate 4x plus 5y over 3x minus y if x is equal to 3 and y is equal to 8. So the first thing I'm going to do is I'm going to plug in my values for x and y. So I have 4 times x is 3 plus 5 times y, which is 8, all over 3 times x, which is 3, minus 8. Okay, now remember the fraction bar counts as a grouping symbol, so I have to simplify the numerator and simplify the denominator before I can cross that line. So I'll draw a little arrow here. So that's going to give me, do my multiplication first. I'll have 12 plus, and 5 times 8 is 40. And this will be 9 minus 8. And then I have 12 plus 40 is 52. And 9 minus 8 is 1. So that's going to give me 52. Notice that I'm using arrows instead of an equal sign. This is an expression, so I can't have an equal sign. So I just use the arrow to kind of show that I'm going to the next step. Normally, we do our things underneath, like here we work underneath. When you have a fraction, it's easier to work to the side, and so just show an arrow that you're going to the next step. Okay, then we get to the try this, and there's a lot of problems on here. Okay, but they're pretty basic. So let me go through them real quick with you. The first set of instructions says simplify each expression. So this is basic order of operations. 4 through 6 says evaluate each expression. They give you the values of the variables. So you're going to plug them in. You're going to follow the order of operations to solve those. On the last page, we've got some more simplifying, okay, and again, this is just following the order of operations. And then we have another evaluate, okay, where you're going to plug in the values for x and y and follow the order of operations. So this shouldn't be too difficult. Show all your work on your paper, and when you are finished, you're going to put your answers into the Google form. Why did this stop?